Okay, let's jump right in. Today we're doing a deep dive on a huge step forward for generalist AI. It's called Nitrogen.
Right. This is an open foundation model from NVIDIA and a few collaborators, and it really tackles what's been the biggest roadblock for training complex embodied AI agents.
And that roadblock has been around for a long time. We've wanted agents that can learn inside these big interactive worlds for decades, but the research always seemed to hit a wall.
It did. And that wall was a data wall. I mean, progress in this field has been totally choked by the lack of massive, diverse, and this is the key part-labeled action data sets.
So you need to know not just what's on the screen, but exactly what button the player was pressing at that exact moment.
Exactly. And trying to manually label, say, 40,000 hours of gameplay is just, it's impossible.
Which is what makes Nitrogen so wild. It's trained on exactly that, 40,000 hours of gameplay from over 1,000 different games. It's a total game changer.
And the breakthrough was realizing the action labels were, hiding in plain sight.
On the internet. How on earth did they do that?
They found this amazing public data source, gameplay videos that have input overlays.
Oh, you mean those little graphics of a gamepad in the corner that streamers use?
That's the one. Streamers put them there so viewers can see their inputs, but it turns out to be the perfect labeled data set for an AI.
I can't believe a feature for viewer engagement ended up being the key. But, I mean, that video has to be messy, right? Different resolutions, different controllers.
Oh, it's incredibly noisy. So they built this really clever pipeline to clean it up. First, an annotation model finds and crops just the gamepad.
Okay, so it isolates the controller?
Then they use a fine-tuned segmentation model, it's called SegFormer, to basically cut out the joysticks and buttons and predict their state.
And that actually worked from compressed internet video.
It worked incredibly well. We're talking about a 96% average button accuracy and a joystick R-squared score of 0.84. It proved you can get clean data from this noisy source.
Wow. But what about bias? I saw the data is really heavy on action RPGs and platformers.
It's a valid concern, but the sheer scale of 1,000 games helped smooth that out a bit. And the accuracy numbers really gave them the confidence to move forward.
So once they had the data problem solved, what did they build? What's the brain of Nitrogen?
The architecture is a vision-action transformer. It's an adaptation of an earlier model, but it's built for speed and generalization.
And it uses a SIGLIP vision encoder, right?
Yes, and crucially, a diffusion transformer, or a DDIT. But instead of generating images, it's been repurposed to generate the sequence of actions based on what it sees.
And it's doing all of this from a single, pretty low-res frame of the game, just 256 by 256 pixels.
Yep. That low resolution is key for efficiency. It lets the model focus on the big picture, not tiny details.
So how do you even test something so general?
That's the other brilliant part.
Here.
They built a multi-game evaluation suite with 30 different tasks across 10 commercial games.
Yeah.
And they used a universal gymnasium API wrapper.
What does that do?
It lets them programmatically control any commercial game without hacking the code. It just simulates perfect player inputs. It's the only way to test for true generalization.
And the model showed strong skills right out of the box, even on games it had never seen.
That's the zero-shot confidence, yeah. But the real headline numbers come from the transfer learning.
Right, because training a model from scratch on a new game is so hard.
It's incredibly data hungry.
Yeah.
But when they took the pre-trained Nitrogen and just fine-tuned it on a new game, the results were amazing.
And what was the result?
Up to a 52% relative improvement in task completion rates compared to a model trained from scratch on that same new game.
52%. That is a massive efficiency boost. It's basically proof that it's learning the common language of gaming.
It is, but with some nuance. It saw huge gains in generic skills, navigation, basic combat. But for really game-specific puzzles or mechanics, the improvement was much smaller.
So it learns the grammar, but it still needs a quick lesson on the local vocabulary for each new game.
That's a perfect way to put it.
So to pull this all together, Nitrogen is this huge open source step forward. It proves we can get past that data bottleneck. But you mentioned it's currently a System 1 sensory model. What does that mean here? Is it just pure reflex?
Precisely. System 1 thinking, in this context, means it's purely reactive. It sees what's on the screen right now and reacts. It can't plan ahead. It can't remember the last room it was in to solve a maze.
And it can't follow language commands like go get the key and bring it back here.
Not at all. It has no long-term memory or planning capability.
So here's the thought we want to leave you with. If Nitrogen has mastered the reactive System 1 behavior for 1,000 games, what's the one ingredient it needs to make the leap? What would it take to turn this world-class reactor into a long-term strategic planner?
Welcome back to the deep dive. If you've ever tried to really manage your own health, you know the feeling. You've got this stack of specialist reports, notes from some wellness app, a lab result PDF you can't even read. It's just chaos.
It's absolute chaos.
And today we're looking at the new dedicated health experience in ChatGPT because it's designed to fix that exact problem.
And that chaos is so real for so many people. I mean, the sources show the demand is already immense. We're talking over 230 million people globally asking health questions on the general ChatGPT every single week.
Wow. Every week.
So this isn't creating a new market. It's just meeting a need that's already there, a huge need.
Okay, so that's our mission today. We're going to dive right in, quickly unpack the features, the privacy stuff, which is critical, and the clinical foundation so you feel ready to use it.
Let's do it.
So let's start with that core function. It's all about solving that scattered information problem, right?
Exactly. The big innovation here is securely bringing all of your health data together, from patient portals, from apps, all in one place with the AI's intelligence.
So for the first time, you can actually see the full picture, not just these little snapshots.
It's the longitudinal picture. That's the key.
So what can you specifically connect right now? What kind of information are we talking about?
Well, for users in the US, a major one is securely connecting your actual medical records. They do that through their partner BeWell.
Okay, so it's like a secure aggregator.
Right. And beyond the clinical records, you can sync your wellness apps, things like, Apple Health, if you're on iOS, of course, and other tools like Function and MyFitnessPal.
This sounds like it goes way beyond just getting a simple summary. So what can a user actually do with all that data combined? Give us a concrete example.
A fantastic use case is analyzing insurance options. It's so complex.
Oh, it's a nightmare.
So by integrating your actual healthcare patterns, how often you see a specialist, what preventative care you use, the AI can basically model your health cash flow against different plans.
So it makes the decision real, not just theoretical.
Exactly. It lets you weigh options based on your personal history. It can also translate those dense test results or help you prep questions for your doctor.
Okay, but you said connecting medical records. We have to address the elephant in the room here. Security. That just sounds like a huge risk to a lot of people.
And it would be if it wasn't handled properly. That's probably the most critical point to understand. The sources really emphasize these layered protections.
So what are they?
ChatGPT Health operates as a completely separate space. It has its own purpose-built encryption and isolation just for health data. It's not a feature, it's a whole compartmentalized environment.
But wait, if millions are already using the general tool, why should they trust this is any different? Is this sensitive data being used to train the models in the background?
And that's the crucial takeaway from you. The answer is an emphatic no. It's explicit. Any conversations, any data within the health space is not used to train the foundation models.
So it stays put.
It stays put.
Yeah.
Any health memories, the context it learns about you, that all remains strictly inside that dedicated, separate space.
That's reassuring. And it also sounds like this wasn't developed in a vacuum. I mean, this was built with physicians, right?
Oh, absolutely. They worked for over 2 years with more than 260 physicians across 60 countries. They logged over 600,000 instances of feedback.
600,000.
It's an incredible volume of input. It shaped everything, from the knowledge base to the safety guardrails, making sure the system knows when to tell a user, hey, you need to talk to a real clinician about this.
And that rigorous physician-led approach, that leads right into how they actually validate its accuracy. Tell us about HealthBench.
HealthBench is their formal evaluation framework. It uses these physician-written rubrics to score the AI's responses against real clinical standards.
So it's being checked against what a doctor would say.
Precisely. The focus is always on safety, clarity, and most importantly, appropriate escalation of care. It's designed to never encourage self-diagnosis or, delay someone from seeking real treatment.
So when you put all that together, what does this actually mean for you, the user? The core message seems clear. This is designed to support, not replace, medical care.
That's the mandate.
The value is really about feeling more confident and prepared when you're navigating your health, and not just when you're sick, but for tracking those wellness patterns over time.
Exactly. And that brings us to a final sort of provocative thought for you to consider.
Okay.
Given this level of personalized data integration and this clinical feedback loop, what new, more complex metrics will you start to expect your providers to discuss with you? Beyond the standard blood pressure and cholesterol check at your annual physical, what comes next? So, Forget the big flashy auto show keynotes for a second.
Yeah, this was different.
Right. Ford's biggest announcements from CES actually came from this much quieter speaker session.
Great minds, they called it, which, you know, is a statement in itself.
It really is. And we've been digging into the sources on this, looking at their big moves in AI and advanced driver assistance systems, or ADS.
And that venue choice, it tells you a lot. I mean, they're signaling that this is about technology and humanity, not just, you know, horsepower and torque figures like the old days.
Absolutely. It's a fascinating pivot. But our mission for this deep dive is to get past the philosophy, right? And really extract the hard timeline. What is Ford actually bringing to market and when? Okay, so let's start with the AI assistant.
The new AI, yeah.
The roadmap seems pretty clear. It kicks off early 2026 right inside the Ford smartphone app.
In the app first, which is a smart, low-risk way to start.
And then the full, native in-car experience follows in 2027.
Right. And what's really key here is that this isn't some crazy, expensive, proprietary AI they built from the ground up.
No, it's off the shelf, basically.
Exactly. It's hosted on Google Cloud using existing large language models, or LLMs. That just slashes the R&D time and cost.
So the real magic isn't the model itself.
Not at all.
It's the data they're feeding it, the deep vehicle access.
That's the differentiator, yeah.
I mean, we're talking about moving beyond just asking for directions. You can ask it these high-level questions like, how many bags of mulch can my truck actually support?
And it knows, because it has the real-time payload data.
Or something super granular like, what's my exact oil life percentage right now?
And this is how they're trying to stand out, from the competition.
Yeah.
You've got Rivian with assistants that can handle really complex navigation, climate control.
And Tesla's integrating Grok, which is wild, generating sightseeing tours on the spot.
Right. So Ford is carving out its niche by tying the LLM directly to the vehicle's guts. It's like your owner's manual just became your copilot.
And that idea of efficiency and cost-cutting, it links right into their other big announcement,
BlueCruise.
BlueCruise Next Generation. And the headline number here, the really big deal for the business, is that it's 30% cheaper to build.
30%. I mean, that is huge.
It's massive.
It's what lets you democratize the tech. If you can slash the costs like that, suddenly BlueCruise isn't just for the high-end models.
It can be standard, or at least a much more accessible option.
Right.
And we even know where it's debuting.
2027.
On that new low-cost EV platform.
Yep.
The Universal Electric Vehicle platform.
Which everyone expects to be that new mid-sized pickup.
Right. And while they're cutting costs, they're also boosting the capability. I mean, they're promising eyes-off driving by 2028.
And this point-to-point autonomy, which sounds a lot like Tesla's full self-driving supervised.
Okay, but hang on. If they're saying eyes off, that sounds like a big leap. But then they also say drivers always have to be ready to take over. How do those two things square?
Well, they don't. Not really. And that's the big unresolved issue for the entire industry.
The legal hurdle.
The legal and the technical hurdle.
Wow.
When they call it supervised, that word is doing a lot of work. It means you, the driver, are still liable. You have to be monitoring, no matter how good it feels, until we cross that legal line into true level 4 or 5 autonomy. That supervision requirement is everything.
So let's tie this all together. The key takeaway for you from this deep dive is that the roadmap is really specific.
Yeah, it's not vague promises.
Exactly. You've got the AI assistant coming to the app in 2026 and then fully in the car in 2027.
And that's paired with the next-gen cheaper BlueCruise also arriving in 2027.
With that eyes-off feature targeted for 2028.
Right. And, let's circle back to where we started, that Great Minds session.
The venue.
The venue. That choice, it signals that Ford sees itself as a software company now, not just a car company. And when you think about that deep integration, well, that's what enables things like long-term subscription revenue.
So the final thought is this.
Yeah. Is Ford betting that the real profit engine isn't just selling you the physical truck anymore, but selling you access to its software, its data, and its services for years to come? Because that is a fundamental shift in the entire auto industry.
Welcome back to the deep dive. Today we are jumping into some pretty explosive financial news around the AI giant Anthropic, the makers of Claude. Our mission here is to really unpack how a company's valuation can, almost double in just 3 months.
And the numbers are just staggering. The latest reports we're seeing suggest Anthropic is looking to raise another $10 billion.
$10 billion, wow.
Yeah, and that would push its valuation to a massive $350 billion. It basically confirms that this AI race is Well, it's an arms race for capital now.
Okay, so that speed, that velocity, that's what I want to dig into. It feels like just yesterday we were talking about their last funding round.
We were, and the context is everything here. Just 3 months ago, they closed their Series F round. That valued the company at $183 billion.
And a Series F is already very, very late stage.
Exactly. So to go from $183 billion to a rumored $350 billion in 1 quarter, you just don't see that. It's truly off the charts. And if you rewind to March, they were at $61.5 billion.
That trajectory is it's aggressive. So who is putting up this kind of money? Our sources are pointing to Coke2 Management and GIC.
Singapore's sovereign wealth fund, yeah.
These are not small-time players. What are they betting on that gives them this much confidence?
Well, it really connects directly to the practical application of their tech. The market isn't just betting on general AI anymore, it's betting on specific tools, especially Claude Code.
Their tool for automating software development.
Right, it's all powered by their latest model, Claude Opus 4.5. And this is the key. It targets the most expensive part of any big company, engineering time. That potential for massive ROI is what's justifying this flood of cash.
Okay, and this is where the story gets really interesting and a bit complex. The compute capacity. We're seeing this huge, separate $15 billion commitment from NVIDIA and Microsoft. But that wasn't just cash in the bank for Anthropic, was it?
No, not at all. And this, I think, is the most important insight from our sources. It's what you'd call a circular deal.
A circular deal. Explain that.
So Anthropic secures that $15 billion in funding, but the deal mandates that they have to turn around and spend $30 billion, double that amount, on compute capacity.
From Microsoft Azure.
From Microsoft Azure, which of course runs on NVIDIA's chips.
So the money they raise is immediately promised back to their partners. The investors are basically selling them the infrastructure they need to use the investment.
You've got it. The capital is buying the right to play. If you connect the dots, you realize the AI race is fundamentally a compute race. You either buy this incredibly expensive hardware or you're out.
And this is all happening while they're prepping for a potential IPO this year. So this is also about positioning against their main rival, right?
Absolutely. It sets them up for a showdown with OpenAI.
So where does this $350 billion valuation put them in that fight?
It puts them as a very clear, very strong number 2.
Yeah.
But the gap is still significant. OpenAI is reportedly in talks to raise up to $100 billion, and they're targeting a valuation of up to $830 billion.
$830 billion, that just puts the scale of this whole thing into perspective.
So really, 2 big themes come out of this deep dive. First is just the insane speed of venture capital right now. Doubling a valuation like this in 90 days is wild. And second is the sheer scale of the investment required. Not just the direct cash, but these massive, non-negotiable compute deals you need just to get in the door.
So what does this all mean for you, the listener? It means the AI market is now being defined not just by clever code, but by the staggering amount of capital needed to run the race. It's like a national-level spending project.
And that leaves us with a really fascinating question for you to think about. When you see your biggest rival targeting a valuation that's nearly 2.5 times larger than yours, does that mean Anthropic's $350 billion is a ceiling? Or is it just the opening shot in the next, even more intense phase of the AI capital wars?